This problem is from 3.5, number 17. Given p of x equals 3x to the fifth minus 2x to the fourth plus 96x cubed, minus 64x squared minus 432x plus 288, and that 6i is a 0. There's a big clue right there. Write p in factored form as a product of linear factors. Be sure to write the full equation, p of x equals, so that's part of the answer. So first of all, if you notice that none of these coefficients are complex, they're all real, there's nothing imaginary, so that means minus 6i is another 0. So we know two of the zeros. It is x to the fifth power, so we know 2 of the 5, right? Okay, so we'll at least get it down to a cubic, and hopefully we see something from there that we can factor. 288's got a lot of factors, so once we get these two into that, it'll come down quite a bit. So let's first try our 6i, and we'll do 3, negative 2, 96, minus 64, minus 432, and 288. So 0, 3, 6i times 3 is 18i. So minus 2 plus 18i is minus 2 plus 18i. 108 minus 12i. Okay. So now we have 6i. Okay, let's go ahead and add that. So that's going to be what? Negative 12 minus 12i. Okay, we keep going here. 6i times negative 12 is going to give us a negative 72i, I should say. And 6i times negative 12i, the I times I is negative 1, so it gives us a positive 72. So if we add that straight down, we end up with an 8 minus 72i. And just trust that this is going to go through. We're told that 6i is a 0. So let's just keep moving along. 6i times the minus 72i, or I guess I could do 6i times 8, is 48i. And then 6i times negative 72i, so 6 times negative 72 is 432, or negative 432, I times I is negative 1, so we get a positive 432. So look at that, that's going to go away. We just have a 48i, and you may guess it, 6 times 48 is 288, I times I is negative 1, so negative 288, and we get our 0. Look at that. So we verified that that's a 0. We brought this down a bit. And look at that. We went from a 288 to a 48. A lot fewer factors with 48. We're going to get down even more now. So if we go negative 6i here, we get 0, 3. Negative 6i times 3 is negative 18i. Oh, look at that. Cleans up nicely. So we have a negative 2 left. Negative 6i times negative 2 is a positive 12i. So we have plus 12i. And that's going to go away. We have a minus 12 left. The negative 6i times negative 12 is a positive 72i. So that's going to be an 8 left. And negative 6i times 8 is a negative 48i. And so all the i's are gone. So you can see, like, clean up on aisle I. Okay. Now, one way I would approach this last part is we could do factor by grouping, and I'm looking at it, and it will factor by group just by looking at this. So this is our constant. This is the x term, x squared and x cubed. So what we have is a 3x cubed minus 2x squared minus 12x plus 8. And if we factor by grouping, I'm going to treat it like this. 3x squared, x cubed, minus 2x squared minus, I'll do in parentheses, is 12x minus 8. I do this minus because this minus times that minus makes it a positive, what we had there. So if I group this part here as well, I can pull out an x squared, and I have 3x minus 2. Out of this other part, I can pull out a 4, and I have 3x minus 2. So I have, how far can I write on this? Oh, look at that, x. Let me write the 3x minus 2 first. So I'll have 3x minus 2 times x squared minus 4. And this would factor to be 3x minus 2 times x minus 2 times x plus 2. So our factors would be this, still in the boundaries of my drawing. Okay, so it's going to be x minus 6i times x plus 6i times 3x minus 2 times x plus 2 times x minus 2. And that's the process. Hope that makes sense.